You can't just distribute the exponent and you've got to expand and FOIL this. So it looks like this. I'm going to multiply the first two terms together, which is 2 times 2, that's 4. Square root 5 times square root 5, that's 5. Then there's a minus next, so minus 2 times 1 would just be 2. Square root 5 times square root 3 would be square root 15. Another minus, because it's 2 times 1, which is 2, root 3 times root 5, which is root 15. And then the last one, negative root 3, and negative root 3 would be a positive 3, because any root times itself gets rid of the root. So I have 20. These two both have the same exact square root, so I can combine those to minus 4 root 15 plus 3, and then there's two constants, so I'm going to combine those to get 23 minus 4 root 15. Now 4 root 15 can't get broken down, right? It would just be 3 and 5, so we leave it the way that it is. Questions on that one? All right, number 2, now we're dealing with the division, right? If we could simplify, if there's a number that would go into both of those square roots, we could simplify. But we can't do the 3 into the 6 because one's outside the root, one's underneath the root. What we do here is called rationalizing the denominator, right? We can't keep that square root in the bottom. So we multiply both the top and the bottom by the square root of 3. So I multiply out what's in the top. 6 root 2 times root 3 becomes 6 root 6. Multiply what's out in the bottom, root 3 times root 3, which is 3. Now this can be simplified because 3 can go into itself once and into 6 twice. And my answer is 2 root 6. Number 3, we're dealing with a product, right? So as it is, I could multiply 22 and 44 out, put underneath the root, but I'm going to want to break these down anyways. So it's best to just keep them separate. 22 is 2 and 11. 44 is 4 and 11, which is 2 and 2. Break down the 4. Now I have 2 2's, which a 2 is going to go to the outside of the square root. The extra 2 that stays underneath the square root. And I have 2 11's. So the 11 comes outside with the 2 that's already there, making this 22 square root 2. Then comes number 4. This time I can simplify because both the 25 and the 75 are underneath the root. So I can say 25 goes into itself once and into 75 3 times. 3 times the square root of 1 is just 3 over the square root of 3. Has to get rationalized, so we multiply both the top and the bottom by the square root of 3. And I end up with 3 root 3 over 3. The 3's cancel, and my answer is just square root 3. Questions on that one? Okay, number 5. Now we've got a square root in the bottom we have to get rid of.
Wait.
Oh.
For 4, you got just square root 3?
Correct.
Okay, thank you.
You're welcome. For 5, we've got a square root in the denominator, and it's got it's an expression this time, which means I have to multiply by the opposite of that expression. I keep the terms the same, so 1 and 3, root 3 stay the same, but I put a plus this time instead of a minus. And I multiply again both the top and the bottom by that. So now I got to FOIL out, remember these are the long ones. I have to FOIL out the top and the bottom. So I'm going to multiply the first 2 terms on the top. 2 times 1, that's 2. Multiply the outer 2 terms on the top, that's 2 root 3. Multiply the inner 2 on the top, that's plus root 5. Multiply the last on the top, root 3 times root 5, which is root 15. None of those can get combined, so that whole thing is my numerator. Then comes the denominator. I multiply the first, and I get 1. The outer, and I get root 3, positive root 3. Inner, I get negative root 3. Last, I get minus 3. If you've done it correctly, the square root should cancel like these do, and I get 1 minus 3, which is negative 2. That goes in the denominator. Now 2 can go into the first term and into the second, but it can't go into the ones that follow. It would have to go into every term in order to simplify this. So we actually leave this entire thing as our answer.
Can you like divide 2 and -2?
But you can't simplify it unless it goes into every single term. It'd have to go into all 4 terms.
Oh, okay.
Yep. So you could change the signs, like you could get rid of the negative if you wanted to. You could change the numerator signs and put it over just a +2, but you can't get rid of the denominator if it can't go into every single term at the top.
Oh, okay.
Good question,
so
Sophia.
Go back to 4.
Yep. So P.3 is called polynomials and special products. And it is exactly that. We're dealing with polynomials, which is an expression that has more than one term. And special products like in parentheses squared or difference to opposite, which I talked about yesterday, that there's like shortcuts for some of the stuff we did yesterday. That's what we're going to kind of talk about. So we start with the basics of polynomials, adding and subtracting polynomials, and hopefully you remember this. But in order to combine like terms, we ignore the coefficient to see if we can combine these. We look at the rest and say the term must be exactly the same as the second one. So if I had a 2a squared b to the third, then I can add that to a 4a squared b to the third because these are exactly the same. On both of those terms, the a is raised to the second and the b is raised to the third. If it's reversed, if it's a 2a to the third, b to the second, plus 4a to the third, a to the second, b to the third, these cannot be combined because the a has a 3 on one of them but a 2 on the other. It has to be exactly the same, obviously without the coefficient. So you get to ignore the coefficient. If they're positive, we're going to add them. If one's positive, negative, we're going to subtract it. Okay, if they're both negative, obviously we add but keep the negative. So all the same rules apply to adding and subtracting. Here's some examples. So let's look at number 1. 4y to the second minus 3 plus -7y to the second plus 9. When there's a plus in between the parentheses, you can literally ignore the parentheses and not change anything. This would still be a -7y squared plus 9. Now look at your like terms. So I've got a y squared here and a y squared there. That's +4 and a -7, which means -3y squared. And then I've got a -3 and a +9, which means +6. So we're just combining like terms here. If there's a negative in between, which we're going to get to in a little bit, you have to change the signs of everything that follows and then combine your like terms. So you do too. You do example 2. So if it helps you to color code it, do it. If it helps you to underline them, do it. Do whatever is going to make sure that you know what you're doing, right? If I color code them, like I have an x to the third, 5x to the third, and a positive x to the third, which really there's a 1 there, which means this is 6x to the third. Then I have a -7x to the second plus 2x to the second, which is -5x to the second. Then I have minus x, and it's the only thing that's got an x, so it stays the way it is. And then I have a -3 and a +8, so this becomes +5. Everybody good on that one? Okay, 3 has a minus between them. So before we can remove these parentheses and combine like terms, this minus has to get applied to everything in the parentheses after it. So if I rewrite it, it'd be 2x to the second plus 1 minus x squared plus 2x minus 1. Now look for my like terms. So I've got a 2x squared and a -x squared. I've got a +1 and a -1. And then I've got the 2x that's all by itself. Highest exponent down to none is how we work these out. So 2x squared minus x squared would be x squared. Positive x squared doesn't have another match, so it's positive 2x stays by itself. Sorry, not x squared, plus 2x. And then positive 1 and negative 1 cancels out. So my answer is just x squared plus 2x.
Shouldn't it be x squared plus 4x because there are two positive 2x's?
There's only so that.
Oh no, wait, no.
You're good. You caught it.
I didn't see that.
That's okay. That's okay. Trust me, I'm gonna make plenty of mistakes. I'm glad that you're watching. Questions? We feeling good about adding and subtracting? Yes, we're good on this. This is a skill we remember. Yeah. Okay. Great. All right. More. I'm gonna give you 2 minutes. Get those done. Nothing new here, just more complicated application. All right, so you should have, for number 4, distributed the negative to everything in the second set of parentheses, making it 7x to the 4th minus x to the 2nd minus 4x plus 2, then minus 3x to the 4th plus 4x squared and minus 3x. Combine your like terms. I should have gotten 7x to the 4th minus 3x to the 4th, which is 4x to the 4th. Negative x squared and positive 4x squared, which is a positive 3x squared, negative 4x and negative 3x, which is a negative 7x, and just the 2 was the only one that was by itself, so that's positive 2. Number 5, you want to do the innermost parentheses first, so I got to take care of what's happening in those brackets, which is y squared plus 1 plus 3y minus 7. That becomes y squared plus 3y minus 6 because of the positive 1 and the negative 7. Then the minus gets distributed to everything after it. And I get y to the 3rd plus 1 minus y squared minus 3y plus 6. And then I want to combine my like terms. So y to the 3rd minus y to the 2nd minus 3y. They were all like individual terms. And then the positive 1 and the positive 6 became positive 7. Questions?
No.
Perfect. Everybody good?
Where did the 6 come from?
This 6 came from me combining positive 1 and negative 7.
Oh, okay.
So that got brought down to here, and then the negative changed it to a positive 6 there. So always
you do the brackets first?
Yep. Take care of your parentheses first. Yep. Think about your order of operations. P comes first, right? Take care of those first. All right. When we multiply polynomials, and we did this with square roots, but now we're going to add in variables. You're going to multiply the coefficients, then multiply the variables with the exponents. You're going to add the exponents if the base is the same, remember. So if I do x to the 2nd times x to the 3rd, it becomes x to the 5th. When you're multiplying binomials, which we did this with the square roots already, we FOIL first, outer, inner, last. And at the end, if there's like terms, we're always going to combine our like terms. And we're going to write our expressions in order from highest exponent down to none. All right, so they look like this. Number 1, we're just doing number 6, we're just doing the distributive property. We're taking that x and we're multiplying it in times all 3 variables. So 3x squared.
Can you go back, please, Miss?
We're doing x times 3x to the second, and this is x to the first times 3x squared, so this becomes 3x to the third. Then we're doing x times negative x, so that becomes minus x squared.
Yeah.
Audrey, you're still unmuted. I don't care, but I just want you to know before you say something super embarrassing for the rest of us. And then x times 1 becomes positive x. There are no like terms, which means that's exactly how it would stay. Up next, negative 3x times 5x plus 2. The negative 3x get distributed. So I do negative 3 times 5, which is negative 15. X times x is x squared. And then I do negative 3x times positive 2, which becomes negative 6x. Again, no like terms. So that's how my answer stays. Eight. I just have 3 terms this time. Same process. Y squared times 4y squared becomes 4y to the 4th. Y squared times positive 2y becomes positive 2y to the 3rd. And y squared times negative 3 becomes minus 3y squared. No like terms, so it stays how it is. The last one is the same process, except it looks like it's after it. I'm still going to distribute. So I can either go this way to this way, or I tend to work my way backwards and do 2y to the third times 2. That's 4y to the third. And then 2y to the third times negative 3y is negative 6y to the 4th. Now, the only thing I'll say here is if this answer is totally cool for where we're at right now. But if you're answering this onto a quiz or a test in Canvas where it's auto-graded, I want you to put it in order of decreasing degree, which means the 6 to the y to the 4th comes first. So negative 6y to the 4th plus 4y to the 3rd. Okay, these mean the same thing, but the second one is in decreasing degree order. So if the directions say decreasing degree, that's what it means. Highest exponent down. Questions on that one? All right, now we're foiling, right? So first, outer, inner, last. All 4 of these are that. All 4 of them have 2 binomials. So we do first, which is x times x, x squared. Then we do squared. Then we do outer, positive 4, positive x, positive 4x. Then we do inner, negative 8 times x, negative 8x. Then we do last, negative 32. This time, I've got terms to combine. Positive 4x and negative 8x means this becomes x squared minus 4x minus 32. Easy stuff, right? We remember foiling. Yes, head nodding. Good, good, good. Just be really careful. 3x times 5x is 15x squared. 3x times 7 is positive 21x. Negative 2 times 5x is negative 10x. Negative 2 times 7 is negative 14. Combine my like terms. 15x squared plus 11x minus 14. Go to 12. 2x times x, 2x squared. 2x times 5, positive 10x. Negative 4 times x, negative 4x. Negative 4 times 5, negative 20. Combine my like terms here. 2x squared plus 6x minus 20. And 13, 7x times 4x, 28x squared. 7x times negative 3, negative 21x. Negative 2 times 4x, minus 8x. Negative 2 times negative 3, positive 6. Combine my like terms. 28x squared minus 29x plus 6. Usual, they just get more complicated. Now we've got 3 variables, right? So we can't say the words like first, outer, inner, last because there's more than 2 in each term. But what we're doing is still using the same procedure, which is distributing, right? So for number 14, I'm going to take that x squared. I'm going to multiply it times all the variables in the second, or all the terms in the second parentheses. So I'd get x squared times x squared, which is x to the 4th. I'd get x squared times 2x, which is positive 2x to the 3rd. I'd get x squared times 2, which is positive 2x squared. Then I go to the next one. Negative 2 times x squared, which, negative 2x, sorry, times x squared, which is negative 2x to the 3rd. Then I go negative 2x times positive 2x, negative 4x squared. Then I go negative 2x times positive 2, negative 4x. Last term, again by all of them, 2 times x squared, positive 2x squared. 2 times 2x, positive 4x. 2 times 2, positive 4. Then the grouping. So I only have one x to the 4th. That's going to go first. I've got positive 2x to the 3rd, negative 2x to the 3rd. Those are going to cancel out. I've got positive 2x to the 2nd, minus 4x to the 2nd. That's negative 2x to the 2nd, plus another 2x to the 2nd. Those cancel out. Then I go negative 4x and positive 4x. Those cancel out. And all I'm left with is a positive 4. So that big whole thing, a lot of them cancel out, okay? Doesn't mean they're always going to cancel out, but just keep in mind that they can. Somebody just asked, is P3 on your first test? Well, yes, but your quiz, which is Friday, this is on it too. P3 and P2 are what's on your quiz on Friday. So keep that in mind. Man, my hair's a mess today. Please ignore. Okay. It's all the stress of the polynomials. All right, number 15. First term, 2x squared times x squared, 2x to the 4th. First term times second term, 2x squared times 3x, positive 6x to the 3rd. Last one, 2x squared times 2, positive 4x squared. Then go to the next one. Negative x times x squared minus x to the 3rd. Negative x times 3x, negative 3x squared. Negative x times positive 2, negative 2x. And the last number 4, 4 to x squared, positive 4x squared. 4 to 3x, positive 12x. This should be squared. And 4 times 2, positive 8. Now we combine our like terms. There's only one x to the 4th. There's an x to the 3rd, an x to the 3rd. So that's positive 6 minus 1, or positive 5, x to the 3rd. X to the 2nd, x to the 2nd, x to the 2nd. Positive 4x minus 3x is 1x squared, plus 4x squared is positive 5x squared. 2x and 12x, negative 2, positive 12 is positive 10x. And our lonely little 8 by itself, positive 8. Questions on that one? So special products almost have a shortcut to it. It doesn't mean you have to use these shortcuts, okay? These are just to help. So if I see two binomials that have exactly the same terms, but one's a plus and one's a minus, then I can actually square the first term, hi brother, square the second term and put a minus between. If I have a plus b squared or a minus b squared, then the pattern is square the first term, and that's the first number. Square the last term, that's the last number. And then double the product of the numbers, and that's the middle term. So these, again, are shortcuts. If they get you, do the long way. If it's a cube, then it's the cube of the first term is the first. The cube of the last term is the last. 3 times the first term squared, second term to the first, plus 3 times first term to the first, second term to the second. And if it's a minus, what changes is the last sign, the alternating signs, second and last, okay? And again, I don't want to stress you out because if you don't get these shortcuts, you can simply just multiply the stuff out. All right, so here's a couple examples with each one. If you look at the first one, right, this is the case where it's the same exact terms, but one gets a plus and one gets a minus. So if I have FOILed this out, I will get the same answer of the shortcut I'm about to use. But the shortcut with this is probably the one that we use the most, and it's easy. You square the first term, so 2x times 2x, or 2x squared, is 4x squared. You square the last term, 3 squared would be 9, and you put a minus between them. Best shortcut ever. Square the first, square the last, put a minus between them. This only works if it's the exact same variable and number combination, but one's a plus in between and one's a minus in between. So same thing for 17, same, but the sign in between. Square the first term, square the last term, and it doesn't matter if it's this one or if it's this one. I get 16a squared minus, because I put the minus between that, 25b squared. Now comes 18, the product, right? This is something squared. So I can choose to rewrite this like this and FOIL it out like we've been doing, or I can use the shortcut, which is square the first term, the square of this, 36x squared, that's the first term. Square the last term, that's the last term. Double the product, so 2 times 6 times negative 5 times x. The product is negative 30, so the sign here matters, times 2, and I get negative 60x. Square the first, that's the first. Square the last, that's the last. Double the product, making sure I keep the sign, and that's the middle. Same thing for 19. Square the first, it's the first. Square the last, it's the last. Double the product. The product here is negative 40x. Double that, and I get negative 80x. All right, it is 1:30. What I will do is work out the rest of these examples. Okay, here are just some more examples. Well, 20 is the product again. Remember, I square the first one, which would be 64x squared. I square the last one, which would be 9. I double the product. So if the product is 24x, I multiply that times 2. It's positive, so it's positive 48x. Okay, here's our first raised to the third power one. So this one's a little bit trickier, okay? If you look back on the example, it was the first term to the third is the first thing. The last term to the third is the last thing. The second term is plus 3 times the first term squared, the second one to the first, plus 3 times the first one squared, or the first one to the first, the second one squared. To be honest, I actually just expand it, but I will show you that shortcut. So I would do 3x plus 2 times 3x plus 2 times 3x plus 2, and I would actually FOIL this out. These two, which I can use that special product, 9x squared, 4, double the product, right, which would be 2 times 6, 12x. I could do that, times 3x squared plus 2. And then I would distribute 27x to the third, 18x squared, 36x squared, 24x, 12x, plus 8. And then just combine your like terms. So 27x to the third, these two combine, 18 plus 36, 54x squared. These two combine, 36x plus 8. I actually think that's easier than remembering the shortcut. If you know the shortcut, then you can use it. But the shortcut for minus, these change signs here. The first, in between the first and second, and in between the third and fourth. So the way this works is this first term gets cubed. So I take x and I cube it, x to the third. Then the last number is this last number cubed, okay? Because it's negative, that's where that negative comes from, negative 8. Then you multiply the two together, but you square the second. So that becomes x squared times the second term, which is negative 2. And you multiply that times 3. So negative 6x to the second. Then you go to the last number. This one here, the last one that's left for us to do. It is 3 times the first term left alone, which is x, and the second term squared, which is that negative 2 squared, which becomes positive 4. Now that becomes positive 12x. So if you keep the signs with the number like we did here, it takes care of these signs. If you ignore the signs and you just do the multiplication, then remember the pattern at the end is plus, minus, plus, minus. All right. Again, if you just multiply those out, the cube ones, they might even be easier just to multiply them out. All right, here we're just, again, foiling, okay? A little bit harder. This one is the one that has the same, or almost the same terms, but look, this is squared and this is raised to the third power. So we can't use the shortcut. We'd multiply these. 9a to the fifth. Then these, positive 12ab squared, a squared, b squared. Then these, inners, 12a to the third, b to the second. Then last, negative 4 times positive 4 is negative 16. B squared times b squared is b to the fourth. There are no like terms, so it will stay exactly like that. This one here, we've got a special product, right? So we could do x squared minus y squared. And then we've got another special product. These are the same except for their signs in between. So we just square the first. X squared squared is x to the fourth. Square the last. Y squared squared is y to the fourth. Put a minus between them. All right, last example, and this one hopefully is super easy. It's just words, so be careful. So subtract this from this, which means I'm going to do 2x to the fourth minus 10x to the third minus 4x minus negative 7x to the fourth plus 5x squared minus 1. This gets distributed. 2x to the fourth minus 10x to the third minus 4x plus 28x to the fourth minus 5x to the second plus 1. Combine my like terms. 2 and 28 is 30x to the fourth. There's no other x to the third. There's no other x to the second. There's no other x to the first plus 1. All right, that's the end of this lesson. I know it was long, but hopefully some of it is review, so it's not too complicated. Have a great day, guys.